Good morning, dear students. Myself, Joyce Stephen. The subject is General Science for Standard 8th. We are going to see the chapter number 3, that is, the name of the chapter is Force and Pressure. Summary of this lesson are contact force and non-contact force, balanced force and unbalanced force, inertia, pressure, buoyant force, Archimedes principle, density and relative density. On last session, we have learned about contact force, non-contact force, balanced force, unbalanced force. Today we are going to see the concept inertia and pressure. Now, inertia. Newton's first law, sometimes referred to as the law of inertia. An object changes its state of motion due to force. In the absence of force, objects exhibit a tendency to remain in the existing state of motion. Let's see the definitions in briefly. The tendency of an object to remain in its existing state is called inertia. This is why an object in stationary state remains in the same state and an object in motion remain in the state of motion in the absence of an external force. Next we are going to see the type of inertia. There are three types of inertia. They are first one, inertia of the state of rest, second type, inertia of motion, third type, directional inertia. Let's see one by one. First one, inertia of the state of rest. For the definition is, an object in the state of rest cannot change its state of rest due to its inherent property. Next one, we are going to see the second type, inertia of motion. Definition is, the inherent property of an object due to which its state of motion cannot change. Third type is directional inertia. For the definition is, the inherent property of an object due to which the object cannot change the direction of its motion. You must have observed inertia of motion. Now we are going to see the activity. Look at the diagram. See, one glass is there and coin is over on there. Take a postcard and keep it on a glass. Next one is, keep a 5 rupee coin on it. Now skillfully push the card. What will happen? The coin straight away falls in the glass. Have you ever done this? Now second, we are going to do the second activity. Hang a half a kilogram mass to a stand with the string 1. Tie another string 2 to the mass and keep it hanging. Now pull the string 2 with a jerk. The string 2 breaks but the mass does not fall. Heavy mass does not move. Now pull the string 2 slowly. The string 1 breaks and the mass falls down. This is because of the tension developed in the string 2 due to the mass. Next we are going to see the topic pressure. You must have observed the tires of two-wheelers and four-wheelers getting pressurized. The air filling machine has a pressure indicating dial or digital meter showing the digital reading of pressure. The machine fills the pressure to a certain value. Next one, the force is to be applied for filling air in the bicycle tire with the hand pump. By applying force, air pressure is increased and then the air is pushed into the tire. This we are used in our daily life. The next one is, are force and pressure related? Now next activity. Look at the diagram. What do you observe? Take some sharp pointed nails and push them into a wooden plank by hammering on their heads. Now take a nail and hold it with this head on the plank and hammer it down from the pointed end. When pressing the drawing pins into a drawing board, they get into the board easily. By applying a force using the thumb, one can push the pins into the board. On the contrary, while pressing ordinary pins into the board with the thumb may get hurt. From this activity, what does this experiment tell? It's very simple. When a force is applied on the head of the nail, it is easy to hammer it into the plank. Next, we are going to see a definition for the pressure. What do you mean by pressure? The force exerted perpendicularly on a unit area is called pressure. Pressure is having a small formula, that is pressure is equal to, that is force upon area on which the force is applied. Next, we are going to see the unit of pressure, that is the SI unit of force is Newton. It is denoted by capital N. Area is measured in meter square. Therefore, the SI unit of pressure is Newton per meter square. It is known as Pascal. It is denoted by PA. In atmospheric science, the unit for pressure is bar. 1 bar is equal to 10 raised to 5 Pascal. Pressure is a scalar quantity. If area increases, the pressure reduces for same force, and if the area decreases, the pressure increases for the same force. Next, we are going to see the example of this. Due to natural adaptation, the bottom surface of camel's feet are abroad. Hence, the camel's weight is exerted on a large area and the pressure on the sand is reduced. This is why camel's feet do not penetrate into the sand and it becomes easy to walk. Now, we are going to see the topic of pressure on solid. Air pressure is exerted on all subjects kept in air. When a weight is kept on a solid, pressure is exerted on it. This pressure depends on the value of the weight and the contact area between the two. Now, we will see the activity 1. Take a plastic bottle and 10 cm long piece of a glass tube on which a rubber balloon can be fitted. Warm up one end of the glass tube and gently push in the bottle at about 5 cm from the bottom. To avoid water leakage, apply molten wax on the side of the glass tube. Now, fill water slowly in the bottle and see how the balloon inflates. Look at the diagram. What is observed? It's very simple. The answer is the pressure of water acts on the side of the bottle as well. Now, let's see the activity number 2. First, take a plastic bottle, pierce it with a thick needle at the points 1, 2, 3. Now, fill water in the bottle up to full height. Water jets will be seen emerging and projecting out. The jet from the lowest hole falls farthest from the bottom. Also, jets coming out from the holes at the same level fall at the distance from the bottle. What is understood from this experiment? It's very simple. The pressure increases as the depth of the liquid increases. Next, we are going to see the concept gas pressure. Take a balloon. If a balloon is inflated by filling air by mouth, it inflates on all sides. If a pinhole is created in the balloon, air leaks out and the balloon does not inflate fully. It is realized that like a liquid, gas also exerts pressure on the wall of the container in which it is enclosed. All gases, any liquids have a common name, fluid. Fluids in a container exert pressure from within on the walls and the bottom of the container. A fluid enclosed in a container exerts its pressure equally in all directions at point within the fluid. Rest of the topic will continue in next section. Thank you so much, dear student.